All right, everyone. My name is Rohan Gulapali. If you're just joining in, welcome to Spark 2021 conference. Our next speaker is Dr. Henrik Christensen. Dr. Christensen is the Qualcomm Chancellor's Chair of Robotic Systems and Distinguished Professor of Computer Science at UCSD. Floor is all yours, Doctor.
Thank you, and I can do sharing. Let me see.
Yeah, you should be able to share your screen.
There we go. Thank you, and thank you for the opportunity to talk about what I do. Let me see here. There we go. So I'm Henrik Christensen. I'm a professor at UCSD. I'm also an entrepreneur, so I've started a number of different companies, and I run an investment fund, so I'm also investing in other kinds of companies. So I have a very varied background. So a little bit about my career overview. I'm Danish by birth, so you can probably hear I have a little bit of an accent. Got my education in Denmark, actually worked on designing automation systems for ships in Denmark. Then I went to college, did research on robotics and use of AI. And as part of that, I went to Oak Ridge, Tennessee, and built a robot that was looking for nuclear waste. So you might not be aware of this. It's a very nice book talking about Richard Feynman, a very famous physicist, called Surely You're Joking, Mr. Feynman. And as part of that, he sort of describes what was going on. So Oak Ridge was the place in the world where they could manufacture nuclear material during the Second World War, during the Manhattan Project. And they left a lot of stuff around the area of Tennessee that still hasn't been found. So I was there 1988 to build a robot that's actually driving through the forest and looking for nuclear waste, which was very interesting. Then went back to Denmark. 1996, moved to Sweden. If you're Dane, this is sort of the worst thing you can possibly do, is to move to the worst enemy, which was in Sweden. And there I led a very large research center. One of the things I did as part of this was I helped design the first autonomous vacuum cleaner. So this was about 5 years before the Roomba came out. So we built sort of the Rolls Royce of vacuum cleaners. It was too expensive. And one of my good friends, Rodney Brooks, said, I can do this cheaper than you can. And then he designed the Roomba, and today 13 million Roombas have been sold. While I was, after I was in Stockholm for 10 years, I moved to Georgia Tech. And what you see, so 2006 was that we built an autonomous driving car, and DARPA, one of the large programming agencies in Washington, DC, had a competition for, can you build an autonomous driving car that can drive around in urban environments and do this? So this was our entry. It was a Porsche Cayenne that we had retrofitted with cameras and LiDAR and all of these things. And then after 10 years in Atlanta doing those kinds of things, I moved to San Diego. The weather out here is fantastic, so why would you not want to do that? As part of my career, not only being sort of a researcher, but also doing this, is that I've spun out a lot of companies. So I'm very interested in how do we actually take research from the university and transition it into the real world. So one of the first companies was a company called Intelligent Machines that helped sort of commercialize some of the things around autonomous vacuum cleaners. Then I helped start a company called United Sciences. I will show you sort of one of the things that United Sciences does is that it has built a very small scanner, really small scanner that you can put into your ears. It was designed so that you can make much better hearing aids. Before, you were barely putting silicon in people's ears and using this as a mold for doing this. By having sort of a small scanner, we could do this. So this is sort of an example of a fully customized earbuds that fit perfectly to my ears. They wouldn't fit anybody else. As part of this, we can not only give you much better sound than you've seen before. But what you see here is also electrodes. And with the electrodes, we can basically measure your brain activities. So you can tell if I'm paying attention or not paying attention. And we can use this to monitor people with stroke and all sorts of things. Then I also used to work with Boeing and said, Boeing drills 1 million holes every year. Why don't we use this to actually do inspection of drill holes so that we can build better airplanes? So that was a company called Aeroscan. Then I helped start a company 2012 called RoboGlobal. RoboGlobal is an investment company that started out by investing in robotics, and today we manage a portfolio of about $4.6 billion of investments. It's not my money, it's other people's money, then we invest for them. Then I started a consulting company to go out and do consulting for various places. And 2 years ago, I started another company, Robust.AI, which is in Silicon Valley, where Rodney Brooks, who's probably one of the most famous roboticists, Gary Marcus, who's one of the most famous people in AI, and I started a company to sort of build next generation robotic systems. The third thing that I do is that, so I came to the US 2006 and was very interested in sort of how can we come up with a strategy for robotics. So I set up a system for writing sort of a strategic plan for what should we do in robotics 5, 10, 15 years into the future. Managed to assemble a committee in Congress that was sort of the recipient of the strategy, half Republican, half Democrats. So I don't care what side of the political aisle you're on, as long as you're a recipient of this. Managed to go and present this to the White House, which resulted in a large national program. Then every 4 years, we do an update. So 2009, we had an economic downturn. So that was very much focused on how can we use robotics technology in various areas to sort of help people. 2013, we had the large earthquake in, just had the large earthquake in Fukushima in Japan. So there was a lot of focus on how can we use robotics technology, drones and other things to actually help the world. 2016, there was a lot of sort of uncertainty about US, China and sort of international relationships, which impacted how we thought about this. And of course, 2020, we're thinking about what's the world going to look like after we get out of COVID. So that's sort of been some of the things that I work on. What do I do on a daily basis? So typically as a professor, you do 3 things. You do research. I'll show you a little bit of what we do in research. I do education. So I work with a number of students, both teaching courses, but also supervising them. And then I'm very adamant about how do we do translation of what we do at the university into the real world through startups and other things. So this is my research group at UCSD, where we have, autonomous driving cars. We have a number of students that work on this, anywhere from undergraduate students to master students to PhD students that work together on building this. My main research is sort of in autonomy. How can we build systems that are robust enough that they can do this? So let's see, I should have a small video. Unfortunately, I'm not sure I have sound. So let's see if you get sound on this. So did you hear the sound? Anybody? I have to see if I can get my chat window up here.
I don't think we can hear it.
Okay, good. Then we will go back. We'll stop sharing and then we'll start sharing again. Share screen, share sound. Do this, and then we will slowly come back over here. There we go. Now you should be able to hear sound.
Hi, I'm Henrik Christensen. I'm the director of the Contextual Robotics Institute here at UCSD. where we do autonomy, smart robots for all sorts of applications. Right here, you're seeing our automated mail delivery system on campus. So the experiment we're trying to do here is to understand how can we use these vehicles for doing micro, sort of the last mile logistics. And it's interesting to try and test these in a campus environment where we have regular traffic, we have pedestrians, we have scooters. So this opens up a number of new challenges for autonomous vehicles. We bought a vehicle, it's retrofitted so that we can do autonomous driving. It has cameras, it has a LiDAR, and it has various other sensors on there. And we've then programmed it so that it would automatically know where it is. It will detect other things around it, like other vehicles and pedestrians. And then we've sort of developed the logic to enable it to participate in traffic, so it can stay on the road, it will stay behind another vehicle. When we get up to an intersection, it will read what other vehicles are at this intersection, whose turn is it, and then it will use this to drive through it. So it will drive just like a regular driver through traffic, except it's all done by a computer. So the technology we're using this is relatively straightforward. We're using LiDAR, we're doing pattern detection to be able to fit into cars, to be able to detect, and we're using sort of a combination of neural networks and traditional programming to be able to do the detection of all the things around us. Then we use sort of traditional programming and planning to figure out, given the current situation, how do we determine what should we do next. So we started this about a year ago to build these vehicles, doing the planning. And now, over the summer, we've started to do automated mail deliveries. We pick up packages here at the mail center, and then we go to, right now, to Warren and Sixth College and deliver to them. Right now, we're mainly relying on using LiDAR to be able to do this. So one of the things we're doing is that we have 6 cameras on this vehicle, using this to complement the LiDAR so we become better at detecting cars, become better at detecting pedestrians. We want to be better at determining the intent. Can we predict if somebody on the sidewalk is about to go onto the street surface? Right now we're only doing mail delivery. We want to get to a place where we can do person delivery, so we can actually have this as a mini bus system on the UCSD campus. So for us it's been important that we're doing this as a joint project between operations and academics. So we're testing this with a mail center to make sure that we are not sort of delivering fake packages or something like that. We actually want to see how can we help do this in a realistic scenario for real-world mail delivery. So that's been very important for us, and for that reason we had a very constructive collaboration with the operations people at UCSD to test the real-world scenario.
So that's very much an example of the kind of research that we do. So David, who is in this video, is one of my PhD students working with one of the mail guys to do this. And of course, we also do a lot of teaching. So I use robots like these to actually train a lot of the AI, a lot of the stuff you saw in the car. We will train initially on these small robots, and then once we've sort of gotten it to a reasonable place. So I teach both an undergraduate and a graduate course, where students learn to do the AI, the robotics, and all of the programming, so that they can actually go and build these kinds of systems. If I look at sort of what is my background, so I got my first degree as a technical college in mechanical engineering, got a master's in electrical engineering and computer vision, and got a PhD also in computer vision. So I have some background in mechanical engineering, some background in electrical engineering, some background in computer science, and then I have an honorary doctorate in engineering that I got 2014. So some of the, one of the questions was, what kind of hardship have you had? So I come from a home where both of my parents had 5 to 7 years of education. None of them had gone to high school. Lower middle class home. I never went to high school. So I actually went and I worked, and through this, then I took sort of a very accelerated high school to be able to get into college. So I did all of the math, physics, chemistry, and philosophy in 1 year. This is the hardest I've ever done in my life. But the other thing was, because I came from a home that had sort of a modest economic background, I worked since I was 14. So I started out by basically cleaning in a bakery store. Then I had a paper route. Then I worked as a cashier in a grocery store. I paid my way through college by being a DJ. So I went to a dancing place, a bar every weekend, every Friday, every Saturday to do this. And then as I got sort of more senior in college, I got programming jobs. So I've had to pay my way through this, and that's been it's been an interesting challenge to pay your way all the way. So if I have sort of some advice I would give to people, I would say, you know, take advantage of all the opportunities. There's so many cool opportunities that are out there now. So if you are robotics, then you know you can go into the US First competition, which is a competition a lot of high schools now have it. It's a fantastic opportunity to learn teamwork, learn all of the different aspects of building sort of what is the equivalent of a small company. And it's also a way of sort of learning how to do project work. I've been a first judge for 10 years by now. But also I would encourage you to go out and do internships with companies. We have interns at UCSD every summer. There's various programs. So this is a way of sort of leveraging this to make sure you get sort of the best possible background. I would also encourage you to find a mentor, somebody who can help you sort of steer the way through this. How do I sort of steer through this landscape? And then I would say, find your passion, figure out where your passion is. What do you really want to do? So I've always been an engineer. I've always been interested in understanding systems, studying systems. How can I build them? So it started all the way back from when I was a kid. You know, my grandpa had a farm. I would take apart any machine on the farm and then put it back together. He was very worried about me taking it apart because was it going to work afterwards? But I had to sort of go and take it apart and understand it and say, that's how it works. And that's been my passion. Because of this, I've been very interested in sort of STEM topics, and I followed that, and that implies that I got better grades. So it implies that, you know, you get into better universities, and if you get into better universities, you typically get better jobs afterwards. So I would say, and I feel this every day. My job is my passion in terms of I do stuff that I very, very much love to do. And because of this, I sort of have fun at work every day because I do cool stuff and stuff. So this is really nice. I work hard, but also I think, the recommendation is nothing, for most people, it doesn't come easy. So, but work hard, but do it with focus. Do it so that you're not spreading sort of your efforts in a lot of different places. There has to be some breadth to it to make sure, because you never know really what are you going to do. When I started my engineering degree in college, everybody said that's a wasted, effort. It's not the right thing to do. 5 years later, there were lots of jobs. So I think that's important. So as a wrap up, I would sort of say, no matter where you're from, what background, you can make it. For me, it's very important. I came from a lower middle class home, limited economic resources. Nonetheless, I've gotten to a place where I'm an advisor to the White House. I've been in Congress. I have, 3 different companies. That's my cat. And I work at a top university as a professor. So, so you can make it. But I think it's very important that you sort of understand the focus, try to focus on what you want to do. And then I always say you should think about what do you want to do 5 years from now. It's important not just to look about what do you want to do next summer, what do you want to sort of, what is your long-term strategy for this? And then I think it's important to pay it forward, pay back to the community. So I love being, a mentor to students. I love being a first judge. I love this, and this is sort of a way through this. I've gotten to know a lot of interesting people that sort of help me on a daily basis. So having this of understanding that giving back is actually very important for this. So I think that's sort of my 20 minutes of giving you a background of where I'm coming from, but I'll be happy to answer any questions And I can, if I can find my mouse, I can stop sharing. I saw there was a question somewhere.
Yeah, I think we're gonna go through some questions real quick. Someone in the chat asked, what advice would you have for someone wanting to pursue a robotics career?
So, typically, the first thing is that robotics is incredibly wide. So I would say, but I would say getting into something like US First or something like that is a great way of getting exposure. It's also a great way of finding local people, local companies that have an interest in robotics, which would open up for internships, going and see what they do. And that way you get to know about, is that really what I want to do? But at the same time, robotics is very multifaceted. So I have people that work on design. I have people that work sort of in mechanical engineering and electrical engineering and programming, in user interaction. So it's very multifaceted. And I think once you start playing with it, you will get a much better impression for where do I want to go with this.
Hi, Dr. Christensen. I'm Darren. I reached out to you, and I had some questions about your career. Like, what was the most interesting project you've worked on throughout your entire career?
So that's a good question. So I would say my two favorite projects is probably the first one we did, sort of the vacuum cleaner, because it was just it's so hard to do, not only technically, but we wanted to do this, and then the CEO for Electrolux, the company we're doing for, said, you have to build this vacuum cleaner and you have to do it for less than $200. I'm like, okay, I have to put in a computer, I have to put in a camera, and when they're like, whoa, this is going to be hard. So not only building sort of the first system with a navigation system and all this, but doing it under those cost constraints was really hard. So that really, really challenged us to be creative. Then I think the other one was the autonomous driving project, the first one we did with a Porsche. I've never been so scared in my life, I have to say, because there is no driver in the car. So when we went to the competition, you would have a USB stick, put it into the car and instruct it where to go, and then you release the USB stick and the car takes off. And you're not allowed to be behind it. I don't think that, you just hope, is it coming back? Is it coming back? And so that's, and these cars are hundreds of thousands of dollars. So that was really scary. But it was also very rewarding. So I had a team of 12 students that were working on that. One of them is now the head of Apple's autonomous driving car, which doesn't exist officially. Another one is, a programmer for a big company in Boston. So they've gone all of these amazing places afterwards. So for them, it was an awesome experience. So it was not only rewarding to do research on sort of something, and back then, this was before we had Waymo, Cruise, all of these companies that are actually doing autonomous driving. So we were very much at the edge, and the students benefited from this, so they got sort of the best jobs afterwards. So I think both the research and the education was very rewarding.
Thank you. That's good to hear.
I think we have another question. How long did it take to build systems of the vacuum, like the Roomba?
So it for the Roomba, it took us about 3 years from concept until we sort of were done. But then the boring part for us as engineers is typically, then it takes another year before it's a product and it's been fully manufactured and sold. So in total, from the starting date until the first units were in the store, was 4 years. 3 years of research and development, and then a year of getting everything sort of ramped up and out. So it was it's a relatively long process.
Hi, I have one more question. Would you consider the most difficult part of your job?
So the most difficult is probably finding time to do all of the things I would like to do. So here's my cat again. But finding time to do all of the stuff that I do. So if you look at it, I do the national strategy for robotics, which goes to the White House. which is an important thing to do. I do, right now I'm still involved in sort of free companies. So the way I do this is that I work 1 day a week in the companies, and then 4 days a week I'm at UCSD. Actually, I'm more like 6 days a week at UCSD because I also work on weekends. But having this of trying to do all of this, of teaching courses, supervising students, doing all of this, is just very, very, time management is hard. But that's, but at the same time, it's so rewarding. I find so much fun in the stuff that I do. So right now I have a project on sort of future manufacturing I'm doing. I have the autonomous driving car. I have a project we're doing on sort of designing a new medical device. So all of these are very different projects, and it's very rewarding for me to see that we're doing things that sort of help people.
One more question. So what classes and like extracurriculars would you recommend for a high school student that wants to get into robotics?
So I would probably say so math is of course incredibly important, because there's at the end of the day it ends up being a lot of math, and then I would say programming, doing programming, because no matter whether you do mechanical engineering or there's just a lot of programming involved in doing this, and today it's most of the stuff we do is probably in Python. So for somebody coming in that has a good background and a good Python background, it will help them significantly in college. But then I would say go out and do, if you can do something like FIRST Robotics or something that's very practical, because by the time we look at you coming to college, we're looking for students that have an interesting story. So it's not just, but more, have you done something interesting, and do you want to do something interesting? Do you have an interesting vision for what you want to do with the rest of your life?
Alrighty, I think one last question. Which skills did you learn in high school that you're still using today?
I'll give you two. So I'm still doing a lot of math that I learned, but I think the other thing is collaboration, working with other people, understanding other people. Work is so important. You might be the smartest person in the world, if you can't collaborate with other people doing projects like you're doing the Spark project here. That's just incredibly important, because no matter where you go afterwards, unless you go to Mars or something like that, you're going to have to figure out how to collaborate with other people. So learning those skills is just crucial to anything you're going to do for the rest of your life.
All right, thank you for your time. I think we're done.